Let's take a look at the necessary steps to configure the Intesis Cascade Controller. For simplicity's sake, we'll use a basic installation as an example limited to 3 heat pumps. As we can see, the Cascade Controller is connected to the heat pumps, a 3-way valve which does not require configuration, a photovoltaic system, and 4 sensors through its analog inputs. In this case, these sensors monitor the following components: a domestic hot water tank, a heating cooling buffer tank, outdoor temperature, and a second domestic hot water tank. The underfloor heating circuit is outside the Cascade Controller scope, hence the red background. With the installation clearly defined, let's see how to configure it. First of all, we open MAPS and go to the Create New Project screen through the Getting Started menu on the left. Here, we can find the Cascade Controller template by selecting Modbus as the BMS protocol and locating the template in the resulting list, or more directly, by typing the order code in the order code field. Double-click to create a new project. This project can be saved as a file to be sent to the controller later on if we are still in the planning phase, and once the installation is operative and we are connected to the controller, it must be sent to the controller. We'll see how to enable this later in the video. Back to the General Configuration tab, we can change the unit's name and the project description here. The connection parameters apply when connected through Ethernet. By default, the IP address and the net mask are automatically assigned via DHCP. However, we can disable DHCP if we need to assign the parameters manually. We'll keep it enabled. Since we will be prompted to create a password when sending the project to the controller, it is a good idea to create one here beforehand. To do so, press the Change button. We can also find the connection diagram here to check the Cascade Controller's connections, as well as some additional settings related to the time configuration and security. The next configuration section relates to Modbus and is used to establish a connection with a BMS. Currently, the only supported connection type is TCP, so you can ignore the other options. Configuration options are straightforward, with the port being the standard one for Modbus TCP, that is 502. The final configuration section is the most important, since it's for the Cascade Controller itself. Here, we will add and configure the different components from our installation. If we are in the planning phase and scanning is not an option, we can enter the units manually. Let's add 3 units. We can select the outdoor unit type in the second column. Besides EHS, HE and HT models are also supported. The indoor unit and the outdoor unit numbers can be modified according to our installation, as well as the description of each unit to better suit our needs. We will also use the following checkbox to indicate whether a unit supports domestic hot water or not. For this example, we will check the box on units 1 and 3. Since units with domestic hot water support can also have an electric heater connected to the hot water tank, this can be specified in the next column. Let's assume the first unit has an electric heater connected. Defining that an electric heater is available allows the Cascade Controller to activate it when necessary. If our installation is already up and running, we can use the Auto Discover function to scan the whole bus. For this, we must be connected to the controller, as you can see by the lower blue status bar. As a reminder, we'll cover the connection section at the end of the video. Press the Scan button to start the process, and then again in the Scan window. After the scan is finished, any compatible units connected to the bus will be detected and listed in the scan results table below. Detected units can either replace or be added to the units currently defined as part of the project. Click Apply to add the units. Keep in mind that the description, domestic hot water support, and electric heater control columns must be configured manually, as we have seen before. Once the units have been enabled and configured, we configure the operating modes next. Heating is selected by default, and the other available modes are cooling and domestic hot water. We'll see them all now, but you should enable only the modes available for your project. The parameters for the heating operation section are proportional band, which is the temperature range below the set point where the controller output increases linearly, from 0% at set point to 100% when this range is exceeded. Integral time, defined in minutes, represents the rate at which the controller corrects accumulated errors over time. And thermal gradient is used to compensate for the thermal jump between the tank set point and the water flow temperature. In the heating operation, 2 set point methods are available. We can choose between a fixed set point or a dependent heating curve. With a fixed set point, we use a constant temperature that the controller will maintain. And with the dependent heating curve, our relation between the outdoor temperature and the required heating supply temperature can be defined through a graphical interface. This option allows the heating system to adjust its output based on the outdoor temperature, which will be monitored through a sensor, as we will see later. For example, at -5 degrees Celsius outside, the system might target 50 degrees for the heating buffer tank. And at 10 degrees, it might drop to 30. Next is the cooling operation section, which has the same parameters as in heating. In this case, the proportional band's role is to define the temperature range above the set point instead of below. Here, the output range increases from 0% when the temperature is at or below the set point to 100% when the temperature reaches the upper limit defined by the proportional band. This lowers the temperature back within the limit. The final operation to configure is domestic hot water. Here we will find the same parameters we are already familiar with from the other operations and 2 additional ones. Priority of domestic hot water over heating and cooling ensures that domestic hot water production takes precedence over space heating or cooling. It's enabled by default, as this is typically the expected and most efficient behavior in residential systems. The 3-way valve self-control option, on the other hand, should be enabled when the units from the installation have an integrated 3-way valve. This is usually the case with split systems. After that, we find the photovoltaic panel section used to cover installations with a Modbus TCP-compatible PV system. When enabled, the following parameters appear. Interval working time, which determines how long in minutes the Cascade Controller will activate the system to increase the set point after detecting surplus photovoltaic energy. And minimum percentage with power excess, which sets the threshold percentage that must be exceeded to keep the system active for another working interval. If this percentage is not reached, the system shuts down for the duration of the interval. Next, we have the meter's configuration for PV, which opens in a new window when clicking the Edit button. Here, we configure the settings to ensure correct communication with the PV system. One crucial parameter is the Modbus register, where we must indicate the address of the PV system register that shows whether we are injecting energy into the grid or consuming it. This register is usually called active power, and the value it uses to indicate surplus may be negative or positive, depending on the equipment. For this reason, it is crucial to select the correct option here. Check your PV system's documentation to determine the appropriate option. The final section to configure is the analog inputs. Here we select and configure each input according to its connected sensor. We know that our example uses 4 sensors, therefore we should enable 4 analog inputs. The functions available to associate to a sensor are heating and cooling buffer tank, outdoor temperature, whose measured values are used for the dependent heating curve set point method we saw earlier in this video, and domestic hot water tank. In this example, the sensor connected to the first analog input measures a domestic hot water tank. The second one measures a heating and cooling buffer tank. The third one measures outdoor temperature. And the fourth and final one measures another domestic hot water tank. Next, we select the sensor type. The supported types are PT1000, NTC10K, or NTC20K. PT1000 is the most standardized sensor type. There are 3 additional options to define: temperature range, offset, and correction factor. These values are usually found in the sensor datasheet. Finally, the unit ID field is where we select the units assigned to each sensor. To do so, we click on the unit ID field and then the gray button. Following our example, the first domestic hot water tank is supported by Unit 1. As you can see, the analog inputs that have the domestic hot water function assigned, like this one, will only list the units that support domestic hot water and are not assigned to another analog input. The heating and cooling buffer tank is supported by Units 1 and 2. And the second domestic hot water tank is supported by Unit 3. As mentioned, we can see that Unit 1 is not listed here since it has already been assigned to the first analog input. Regarding the outdoor temperature sensor, it shouldn't be associated with any unit since it's completely independent. Having completed this process, we can go to the Signals tab, where we can see all the signals handled by the Cascade Controller. The number of signals will vary depending on the operating modes and the number of units enabled, among other factors. In this case, we can see the heating and cooling set points, both related to the heating and cooling tank. 2 domestic hot water-related set points, 1 for each domestic hot water tank. And 3 signals registering the actual temperature, 1 for each enabled sensor. When there are multiple tanks of the same type in the installation, like the 2 domestic hot water tanks we have here, their related signals will be numbered, with signals of the first unit associated with a type ending with 1. Signals of the next unit with the same function ending with 2, and so on. This order is followed regardless of whether these inputs are consecutive or not in the analog inputs table. All that matters is having the same function associated. We are almost done. All that's left is to save the configuration and upload it to the Cascade Controller. This is done in the Receive Send tab. But to enable this function, we must connect to the controller beforehand. To do so, we head over to the Connection tab. We can connect via IP or USB. When using the IP type, as we are doing now, remember to update the password with the one we defined in the General section of the Configuration tab. Select the controller from the Discovered Gateways list and click the Connect button. When the lower status bar confirms the connection has been established, we can return to the Receive Send tab and send the project. And this completes the equipment setup. Happy cascading!